habitat for our species. Among the surprises, we have managed to avoid an ice-free Arctic Ocean projected to occur in 2016, plus or minus 3 years. This linear projection appeared in a peer-reviewed article published in the 2012 edition of Annual Review of Earth and Planetary Sciences. Such an event, and the exceptionally rapid change in global average temperature to follow, would cause loss of habitat for human animals in very short order. It would probably take all life on Earth, too, because the rate of melting is proceeding so rapidly. We have also managed to survive a pandemic so far. The reduced industrial activity associated with the pandemic likely would have caused loss of habitat for humans throughout the world had the first or third waves of the pandemic occurred during the growing season in the Northern Hemisphere. After all, the Northern Hemisphere harbors most of the terrestrial surface of Earth, as well as most of the humans and most of the vegetation. There are other means by which an existential threat could manifest quickly. For example, we are facing what has been called the Macpherson paradox by my online acquaintance and supporter, Bill Eddy. Briefly, it goes like this. Civilization is a heat engine regardless how it is powered, a conclusion based on the laws of thermodynamics and reported in at least 5 peer-reviewed articles by Professor Tim Garrett at the University of Utah. As I have pointed out previously, a paper by Burke and colleagues published on December 26, 2018 in the customarily conservative peer-reviewed Proceedings of the National Academy of Sciences indicates, quote, climates like those of the Pliocene will prevail as soon as 2030, end quote. Mid-Pliocene temperatures were at least 2°C warmer than today. Never mind that the representative concentration pathways used for this study overlook a few dozen self-reinforcing feedback loops and the aerosol masking effect. Any informed look at RCPs, representative concentration pathways, will reveal the rapidity with which global overheating makes them obsolete. As a conservation biologist, I cannot imagine habitat will remain for humans, or many other species for that matter, in the face of such rapid environmental change. Civilization is a heat engine, but slowing or stopping civilization heats Earth even faster than the ongoing planetary heating resulting from this set of living arrangements. The impact of the aerosol masking effect has been greatly underestimated, as pointed out in a February 8, 2019 article in Science, and then again in the July 18, 2019 issue of Geophysical Research Letters. As indicated by the lead author of the former paper during an interview on January 25, 2019, quote, global efforts to improve air quality by developing cleaner fuels and burning less coal could end up harming our planet by reducing the number of aerosols in the atmosphere, and by doing so, diminishing aerosols' cooling ability to offset global warming, end quote. The cooling effect is, quote, nearly twice what scientists previously thought, end quote. Bear in mind that the loss of aerosol masking will quickly warm the planet. However, the resulting impacts on humans must be mediated through the reaction of other organisms. The life cycle of all plants, including crops, follows seasonal patterns. As a result, immediate warming of Earth will not cause instantaneous loss of habitat for human animals. In summary, there's no turning back. We don't have a time machine, which indicates that we can neither maintain industrial activity, which is overheating the planet, nor can we reduce industrial activity, which will reduce aerosol masking and therefore ratchet up overheating very rapidly. We're done, and we are taking the living planet with us. I'm as displeased as anybody else by the consequences of our societal actions and therefore the short remaining time for our species. My recent scholarly work depends upon the research of others. I'm only the messenger. Summarizes self-reinforcing feedback loop number 6 in the essay with a focus on peer-reviewed papers and assessments from national level governments. Greenland ice is darkening, according to a paper in the August 8, 2012 issue of the Cryosphere. As reported in the June 8, 2014 issue of Nature Geoscience, quote, a decrease in the albedo of fresh snow by 0.01 leads to a surface mass loss of 27 gigatons, end quote, annually. Any reduction in albedo is a disaster, says Peter Wadhams, head of the Polar Oceans Physics Group at Cambridge University.
A paper in the December 2014 issue of Proceedings of the National Academy of Sciences provides the first comprehensive picture of how Greenland's ice is vanishing and concludes, quote, that Greenland may lose ice more rapidly in the near future than previously thought, end quote. Research reported in the December 17, 2015 issue of Nature calculates spatial ice mass loss around the entire Greenland ice sheet from 1900 to the present and finds, quote, that many areas currently undergoing change are identical to those that experienced considerable thinning throughout the 20th century, end quote. According to one of the paper's co-authors, quote, the average mass loss rate over the past decade is much larger than at any time over the past 115 years, end quote. Adding to the rapidity of ice melt on Greenland is cloud cover. A paper published in the January 12, 2016 edition of Nature Communications shows that clouds are playing a larger role than previously understood in heating the Greenland ice sheet. Clouds trap heat on Greenland, thus accounting for as much as 30% of the ongoing melt of the ice sheet. According to a paper in the March 3, 2016 issue of the Cryosphere, the darkening of the Greenland ice sheet started becoming significantly less reflective of solar radiation from around 1996, with the ice absorbing 2% more solar energy per decade from this point. Quote, future darkening is likely underestimated, end quote, according to the paper's abstract.